For the result, in table 1, the assigned material properties of this brake rotor. Number 1, the property is Young modulus. Value is 211 gigapascal. Number 2, Poisson's ratio 0.291. Number 3, density is 0.008 giga over millimeter cube. Number 4, thermal expansion is 1.21 times 10 negative 5 Kelvin per degree. Number 5 is yield strength 0.31 gigapascal, and number 6 is and the material name is iron. So for the result in table 2, the assigned material properties of this brake rotor, which is ventilated frequency, is number 1, we are using the 2346 Newton load. The outcome for this load is the maximum von Mises stress. The value is 899 gigapascal. The minimum von Mises stress is 11.8 gigapascal, and the translational displacement is 759 millimeter. Number 2, we are using 3346 Newton. The maximum von Mises stress for this load is 904 gigapascal. The minimum von Mises stress is 10.4 gigapascal, and the translational displacement is 759 millimeter. Number 3 is 1346 Newton load. The maximum von Mises stress is 904 gigapascal. Minimum is 10.4 gigapascal, and the translation displacement is 759 millimeter.
Next, for table 3, assign material properties of this rotor for ventilated static. Number 1 is for load 2346. Maximum von Mises stress value is 0.00479 in unit gigapascal. For minimum von Mises stress 0.000188 gigapascal, and last for translational displacement is 0.00154 millimeter. Second load is 3346 for maximum von Mises stress 0.00677 gigapascal. Minimum von Mises stress 0.000188 gigapascal, and last is translational displacement is 0.00155 millimeter. Last load is 1346 for maximum von Mises stress. Value is 0.00283 gigapascal. Minimum von Mises stress 0.000188 gigapascal, and last is translational displacement is 0.00154 millimeter. Next, for table 4 is assign material properties of this brake rotor for solid frequency. Number 1, for load 2346 is maximum von Mises stress is 685 gigapascal. For minimum von Mises stress 5.6 gigapascal, and last translational displacement 561 millimeter. The second load is 3346 for maximum von Mises stress 700 gigapascal. For minimum von Mises stress 4.93 gigapascal, and last translational displacement 561 millimeter. And last, for the load 1346 for maximum von Mises stress 700 gigapascal. For minimum von Mises stress 4.93 gigapascal, and last translational displacement 561 millimeter. Lastly is table 5, assign material properties of this brake rotor for solid statics. First load is 2346 for maximum von Mises stress 0.0021 gigapascal, and minimum von Miser stress 0.000175 gigapascal, and last translational displacement 0.00131 millimeter. Second load is 3,346 for maximum von Miser stress 0.00211 gigapascal. For minimum von Miser stress 0.000175 gigapascal, and last for translational displacement 0.00132 millimeter. Last for load 1,346 is maximum von Miser stress 0.0021 gigapascal. For minimum von Miser stress 0.000174 gigapascal, and last for translational displacement 0.00131 millimeter.
Next, for the calculation of the safety factor, the equation is yield strength over maximum von Miser stress. For the load 2346 Newton, the answer is 0.000345. For load 3346, the answer is 0.000343. For answer load 1346, 0.000T43. This is for the ventilated frequency. Next, for solid frequency, for the load 2346, 0.000453. For the load 3346, the answer is 0.00443. For the load 1346, the answer is 0.000443. For result number 4, result comparison for safety factor for different type geometry. Based on the calculation, the solid disc brake rotor has slightly higher factor of safety compared to ventilated disc for all applied load. For the ventilated disc, the FOS value are around 0.00034, while for the solid disc, the FOS value are around 0.00045. This shows that the solid disc can resist stress better than ventilated disc under the same load condition. However, all the FOS value are much lower than 1, which means the design is not safe according to the engineering standard. This happens because stress value obtained by the frequency analysis are too high and unrealistic. The results are likely affected by unit error or incorrect boundary condition in the computer-aided engineering setup.
For discussion, from the computer-aided engineering results, the von Miser stress increases when the load increases for both these types. The ventilated disc shows higher stress compared to the solid disc because the ventilation holds reduced material and creates stress concentration areas. The solid disc has a higher factor of safety because it has more material and higher stiffness. On the other hand, the ventilated disc is designed to improve the heat dissipation, which is important during braking, even though it was lower structural strength. It is also observed that the frequency analysis results are not realistic as the stress and displacement values are extremely high. The static analysis results are more reasonable and better represent actual braking condition. This shows that selecting the correct analysis type and unit system is very important in computer-aided engineering simulation.
Okay, so thank you to my fellow friends. And for conclusion, the lab that we have successfully demonstrated the design and analysis of a disc brake rotor using CAD and CAE software. Both ventilated and solid disc brake rotors were analyzed under different loads. The results show that higher loads
causes higher stress and displacement. The solid disc rotor has a higher factor of safety and better structural strength, while the ventilated disc rotor offers better heat dissipation. Even though the factor of safety values from frequency analysis are very low, this lab helped improve understanding of finite element analysis, stress behavior, and brake rotor design. And that's all for the conclusion. Thank you.